Hi there guys, my name is Mark Davis, also known as MBD, and this is the last in the current series of Methodoku Masterclasses. Now it's been a funny old set of videos, slightly shaky, somewhat bizarre at times, but I hope you found them enjoyable and useful. And in this last video of the series we're going to look at a really difficult Methodoku. So we're going to go right to the deep end of the pool and look at a fiendish puzzle. Now, I'm going to go through it quite rapidly, so you might not immediately follow all of it, but I hope if you have a look back, it'll gradually begin to make sense, and at least it'll give you some idea about the kind of method knowledge that you need to apply to these Methodokus at the top end of the difficulty scale. Right, let's get started. So, roll up our sleeves, get our pencil sharpened, and let's have a look at this puzzle. So, as you can see, it's an 8-bell grid. It looks pretty big, lots of blank space, not many clues. That's quite intimidating, isn't it? But we can do it, have confidence. So, there are some extra rules with this puzzle, as is pretty common for the harder ones. So we've got no more than 2 blows in one place, which is a rule we're hopefully familiar with. We've got double palindromic symmetry. And what that means is it's not just symmetrical from top to bottom, but this grid is also symmetrical left to right. And ringers will know that as, the back work is the same as the front work. And there's also a 7-lead plane course. So we need to take all those extra rules into account when we solve this puzzle. So let's look at the treble path first of all. I can see, because the treble's down here at lead right at the end of the Methodoku, that the treble's a hunt bell. But I don't yet know what its hunting path is. It looks like it might well be something like a surprise method, but we need to find out. So the first thing I'm going to do is actually count the length of the lead to work out what kind of lead it is I'm looking at, and where the half lead might be. So here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I'm going to stop there and just mark the 16th row because I think that's about halfway. Certainly looks it. We'll see when we finish counting. 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. Right, that's the end of the lead at 32 rows. Well, there's this extra final row, which we call the lead end row, final row of the Methodoku. But as you're probably aware by now, that's actually the start of the next lead. And certainly the lead end pivot, the point of symmetry for our vertical palindromic mirror there, is at this point here. And this is the other one at the half lead. But this method is not just palindromically symmetrical, it's got double symmetry as well. So in order to help solve that, I'm going to work out where the quarter lead pivot points are as well. So 32 changes divided by 4 is 8. So we'll mark that at 8 changes in. 1, 2, 3, 4, 5, 6, 7, 8. There we are. That's the quarter lead in the first half of the lead, and then working backwards, 1, 2, 3, 4, 5, 6, 7, 8. That's the quarter lead in the second half. Okay, so now we'll try and mark the position of the treble in. So the first thing I know is by palindromic symmetry, if the 1 is at lead in the first row, then it must be in the same place in this penultimate row. So we know the treble leads full, and therefore it must come away from lead, like that, to avoid no more than 2 blows in one place. And by the left to right symmetry, what it does at the front, it must do at the back. So what happens at the lead end here must happen in reverse at the half lead. And there we are, we can pencil in those bits. And now I can do a bit more. Looking at these clues here, we know that the treble can't make a long places, can't actually dodge in 6, 7, because that would introduce a long place at the back. So the only option is to dodge 7, 8. And so we can actually apply that to all these other positions here by the 2 types of symmetry that we have. And again, we've got a bit we can join up, so the dodge carries on into the next place, like that. And looking here, we can join these 2 bits up. So the treble can't dodge back to 2, 3, that wouldn't be no good anyway. Can't make a place, it's got to dodge in 3, 4. So here we go. That means it got a dodge in 5-6 from the back. And let's put all these dodges in, and now I can join that together with that clue. And so we've got the treble path completed via the rules of the puzzle. And as you can see, it is indeed a treble dodging path. So we could have a surprise method, but it could also be a treble bob or a delight method. We'll find out as we solve it. Now, having done the treble, next thing to work on is obviously the working bells. There are 7 of them. I think they must all be working bells because of this 7 lead playing course. What can we do? Well, I always like to start off with a 2 because you can usually do quite a lot. It usually has to work with the treble at the start, and this is the path that we know it must take following all the rules. And lo and behold, now I can see that it's colliding via the vertical symmetry with the 7. So the 7 must follow what the 2 did in reverse back down to the lead end here. And indeed the 2 and the 7 are partner bells, and they need to cross at the half lead. So I'm going to mark them here to remind me of that, and they swap positions at the lead end, at the handstroke lead. So that's great. That's really useful. I don't yet know where they're going to cross at the half lead. Could be in any of these positions. But let's look at some of the other clues and see whether we can work that out. So I see I've got the 2 here down in the bottom half. That's crossing the treble here through this transition. So I know it must be the 7 in the same position in the first half lead. And actually we can do a little bit more, can't we? The 7 is kind of blocked by the 3, so it must make a place and then come away from the place. And indeed that must happen in reverse on the other side of the quarter lead by the double symmetry that we've got. And I can do the same thing down in the second half lead, like that. But notice something very useful here. Because the 7 is crossing the treble at the quarter lead, it must be the pivot bell for the quarter lead symmetry. I'm going to note that there. And so it must end up in 7th place at the half lead. It must follow its own path back, but in reverse on the front. So not only is it reversing up top to bottom, but it's reversing left to right. And it ends up in 7th place, not here, but 7th place in a reversed row. So 1, 2, 3, 4, 5, 6, 7. There we go, like that. And whenever we work with methods with double symmetry, we've got to remember this strange thing that, what happens on the back happens on the front. So sometimes we have to reverse the change to make deductions about what's going on. And where you've got a bell which is the pivot bell at the quarter lead, then it ends up in its own place but in reverse. So count from the back. 1, 2, 3, 4, 5, 6, 7th place. Okay, so that is a really useful technique for working with these fiendish puzzles with that kind of symmetry. Now we can look more at the half lead. We can tell now that the 5th has to make a place, so that's really good. It must be the pivot bell for the palindromic symmetry. Let's note that there. And therefore it must come back to its own position at the handstroke lead. Fabulous. And now we can put in the 2 because we know that's the partner bell by the palindromic symmetry for the 7. So we've already made quite a lot of progress here. In fact, we know there's a cross now in 1, 2, which means there must be a cross in 7, 8. So 8, 7 must start like that. And in a minute, we're going to finish with the bottom half of the puzzle and get everything to the top and only work in the top half. But we're not quite there yet. We need to study that half lead a little bit more, and again using what we know about double methods. So notice that the 5 is in 8th place here if we count from the back. 1, 2, 3, 4, 5, 6, 7, 8. So that must mean the 5 and the 8 are partner bells at the quarter lead. And indeed the 8th must fall into 5th place at this half lead, this handstroke half lead. We can reason something similar for the 2. The 2's in 6th place, and so the 2 and the 6th must be partner bells at the quarter lead, and the 6th must be in 2nd place at the half lead. So there, 1, 2. Now, looking at the quarter lead, we've basically got all the partner bells sorted apart from the 3 and 4. They must also be partner bells. One must be passing through the treble here, somewhere around here, and the other one up here. They must be matched but opposite, left to right. And so the 4 and 3 must fall into each other's positions at the half lead, like so. So 1, 2, 3, the 4's in 3rd position, 4, the 3rd is in 4th position. And lo and behold, that gives us, almost as if by magic, our half lead palindromic partner bells. So the 3 and the 8 must cross, and the 4 and the 6 must cross. Let's write those boys in, 3 and 8, 4 and a 6. So now we've pretty much solved the symmetry of the method, and I can now bring up all the clues from the bottom half to the top half. I think actually there's only one left, which is the 6 here. And the partner bell is the 4. The place it needs to go in the top half is here. And there we go, we can now ignore the bottom half and solve entirely in the top half. Isn't that fantastic? So what else can we do now? Well, I think that the position of the 4 here is interesting, isn't it? It needs to come out to reach, it needs to come away from the 3rd to reach that. So the 3 needs to make a place to let that happen. I wonder if we can do something else with the 3. We know it's on the front here, and actually that means we can pencil in its partner bell in its opposite position, which is the 4, by the left to right symmetry here. So we've got quite a lot done there. But how does the 3 join up from the start to this position on the front? Well, it must transition through the treble, either through the 2-3 or by dodging in 3-4. And I don't think it can dodge in 3-4 because it can't make long places, and it can't dodge in 2-3 because that would lead long places on the front. So the 3 must transition through the treble in 2-3 here. So that makes a point there. We can't join these bells up yet, but I think the other great thing about what we've done now is that we've moved all the clues from below the treble to above the treble, and we can now work entirely in this kind of triangle. So we've almost reduced the size of the puzzle down using the symmetry of the method. So now we can have a closer look at the 4 and join it up. I think it has to come away there, and the 5's got to come down this way. We can't quite, we don't know whether 5th place or 6th place is made in the path of the 4 there. But we do know the 4 also has to transition through the treble in 6-7, which is the opposite of 2-3 by the left-right symmetry, because it's the partner bell. So let's just fill in a bit more at the back here. So we've got the work at the back mirrored with the work at the front. We won't bother with anything else below the treble because we're working just in this triangle. So we've only got 2 transitions through the treble left. We've got this 3-4 dodge and we've got the 5-6 dodge. And we know the only bells left to move through the treble are the 5 and the 8. But we actually don't know yet whether the 8 comes down through here and the 5 goes that way, or whether the 5 comes down there. So let's look at that a little bit more. So the 8 looks like it can make the 3-4 dodge all right, but actually then the 5 is kind of blocked, isn't it? This little knot with the 4 and the 7 stops the 5 getting out to the 5-6. So actually the 5 must be the bell that comes into 3-4. Must make 4ths and go through like that, and then its partner bell, the 8, is then in 5-6. So that's fantastic. Now we need to figure out what goes on. We've got only just got this little 4-bell grid now, haven't we? So we surely can figure that out. So obviously the 6th must make 6ths, fill in that hole there, and then it must move into 5th place or up to 7th place. But it's not obvious which. But I'm going to try and join up the 7 next. So how does the 7 get from the back there to, you know, this nice run through of the treble in 4-5? Unfortunately, there's 2 ways. It could stay at the back like this, move away and make 6ths, or it could probably do a dodge and then come through, and we don't really know which yet. But I don't think this looks very promising, because if you imagine, let's write that in, imagine the 7 doing that, then the 4's got to go here, and we've got this big jump, haven't we? That breaks the basic rules of the Methodoku, so that definitely won't work. So I can rub that out. 7 can't stay at the back, so it's got to come into 7th place. Again, it can't follow this path for the same reason, so it's got to dodge back and then come through this way. There we go. So that's some classic old-fashioned Methodoku bell path reasoning there. And now the 6th can't stay in long places, it needs to come back there. And again, the bells are made a place here, so they need to move apart. And we've got this looking pretty nice now, haven't we? The 8 must come down to 6th place to avoid long places in 8s. And we've pretty much got the Methodoku solved. They must dodge. There we go. I think we've cracked it, haven't we? I'm just going to continue this work at the back on the front so we can get the place notation out. So 6 and 4 are dodging on the back by the double symmetry. They must dodge on the front. And what happens here at the quarter lead? Well, we need to mirror, the place notation above the treble beneath it. So where 6 is made, thirds is made, and in 7/8 there's the dodge. And now we finish the quarter lead. We can get the place notation out pretty much for the whole method. Let's do that now. Start with a 3/6, then it's a cross, then 5/6 is made, 1/4, 5/8, that's a cross, all bells change, another 5/8, and as we said at the quarter lead, we've got 3/6. And then, because it's a double method, this next quarter lead is basically this one backwards, but reversed left to right as well as top to bottom. So we've got to move the places that were at the back to the front, and vice versa. So this one, instead of being a 5/8, it's a 1/4. Cross is unaffected. Again, the 5/8 becomes a 1/4. And the 1/4, the places that were on the front come to the back, so that's a 5/8. 5/6 becomes a 3/4. Cross, and then 3/6 is the same, is not affected. That's symmetrical, left to right. And we've got a 1/8 half lead. Therefore, we must have a 1/8 lead end because it's a double method. These two things must be the reverse of each other. And lo and behold, we've got the place notation for the whole lead. We've solved it. Let's quickly look that up. Turns out that's a method called double. We knew it was double, so that's good. Glasgow surprise major. Not Glasgow surprise major, but double Glasgow. There we are. Fantastic. Right, well, I hope you enjoyed that. I hope you followed some of it. It might pay just running that back through, I went through it at some speed, so run it back through and see whether you can follow my line of reasoning. But that's how we should tackle these really hard Methodokus at the fiendish end of the scale. Okay, right, that's it for now. I hope you've enjoyed the series. I hope you enjoy solving the Methodokus, and I hope you've learnt a little bit about methods in the meantime. Thanks very much, guys. Goodbye.